Okay, Mr. Müller. Let's just leave it like this. Okay.
Yeah.
Okay, with core markets like wind power plants, shipbuilding, or automotive industry, Gräbener already has a broad view on machines. Could you please give us a small overview of typical solutions and services that you offer?
Yeah, Graebener was founded in 1921 as a family-owned company, and we own expertise in the forming, milling, and technology. We provide solutions for our customers in the shipyard building industry. Here we provide especially full automatic assembling lines for tailor-welded blades with integrated milling technology and laser welding technology. For the tube manufacturers, we provide nearly all machines for the tube manufacturing of longitudinal seamed pipes. Here, for example, we offer crimping presses, tube forming presses, but also the milling machines. For the wind tower manufacturers and vessel manufacturers, we provide 3- and 4-roll bending machines. And in the automotive sector, we offer the hydraulic presses for hydroforming and hot forming. And based on this expertise in the in the automotive sector, this is especially for hydraulic presses, we started in the new technologies department to develop a special hydroforming press for metal microstructure blades.
Okay, and you are part of the in-house department research and development. Do you think this research and development is the basis for an enduring economic success for a company today?
Yes, I do, because further developments for our own products, but also for new developments, ensures leadership. With these new developments, we can help our customers to fulfill their production tasks. And this is, of course, important that our customers have a better production solution as compared to the competitors.
So you help your customers to improve their production,
their processes,
your research.
Yes. Okay.
All right, and since when, now getting a bit closer to the topics, since when you offer solutions for the production of microstructure plates?
Yeah. Since 2003, we have been developing production equipment for the forming of metal microstructure plates. These activities was forced by the fuel cell market. We still further develop this technology and all the subsequent processes to be able to provide our customers a cost-efficient and optimized production solution.
I think about heat exchanger plates. Is this a topic for you too?
Yes, of course. Due to this hydroforming technique which we use, we are also able to form plates for heat exchangers. But there are many applications where you can use this high-pressure metal sheet forming to develop and produce parts.
Okay. Now let's have a look a little bit deeper to the topic. What exactly do you offer your customers who want to produce such microstructure plates?
Yeah, the range of service from Gräbener is that we start typically with the engineering service and prototyping. That means that we first analyze with a customer together their functional design. We make a feasibility analysis of the design and then optimize the design regarding manufacturability for the forming and cutting and welding of the blades. Finally, we come to the next step. The next step is the prototyping. This means the first tryout of the tools and fixtures, and then make the first demonstrators for our customers. In the second phase, we provide the small series, or we can provide the small series production. That means we can produce parts up to a quantity of approximately, let's say, 10,000 parts. And in the final step, we we engineer and develop the customized production equipment for the high volumes.
Okay, and you several times now said that you are using the hydroforming. Can you tell us why you decide for hydroforming? Because until now I thought the stamping presses are standards in the production of plates.
Yeah. Hydroforming is compared to standard or conventional stamping has some economical and technical advantages. One of the most important advantages is that we have a gentle forming process where we can form pre-coated materials without any damage due to tool contacts and friction. Another advantage is that we can achieve the best dimensional accuracy and the highest reproducibility between the parts. And another advantage is that this technology, hydroforming or hydraulic press from Gräbener, is really you can cost-saving ramp up this system for higher volumes as compared to conventional stamping press.
So does it mean it's more easy to go into the serial production with the hydroforming?
Yes, because you can do it step by step. That means for the first part, we make also consulting for the ramp up. You can install one forming press and form one plate. In the next step, you integrate a second press into your line where you form both the anode and the cathode plate if you have different anode and cathode designs. And then, so you can easily ramp up the volumes step by step, and you can split your invest.
From the point of your customers, can you give us maybe one or two examples which quality requirements your customers ask for in the preparations talks?
Yeah, the quality requirements of our customers are really diverse. A major requirement of the customers is that the tolerances of the channel height over the entire metal plate should be really small. This has to do something with the compression in the fuel cell stack and the fuel cell cell. This is one major requirement, that we have a high accuracy, and of course that the service quality is good.
So what I already found out is that your machines also can handle ultra thin thickness material. Why do we need such a thin material? What do you think?
Yes, there is a demand from our customers, especially for mobile applications, that we have an increased power to weight ratio. That means if you have half the material thickness, you have half the weight of the metal bipolar plates. That is one major issue. And of course, if the material is thinner, you can form more smaller features, because on one side you have to take into account the material thickness.
So it has to do with the size and with the power and the ratio for the mobile applications at least.
Yeah, and especially with our hydroforming technique, where we just using one die on one side, on the other side the water under high pressure. We are not sensitive to position tolerances and are not sensitive to material thickness variations. We can really nicely form thinner materials, for example, stainless steel with a material thickness of 50 micron, and we get really high accuracy in this kind of products.
Yeah, and can you say something about maybe the usage of pre-coated material? I can imagine this could be even much easier now with the pre-coated material than in a stamp.
Yeah, of course, because the pre-coated material needs a gently forming process where you have less contact and friction to tools. Here we see advantage of our hydroforming technique, because as I already explained, on one side we have the tool, on the other side we have water. On the water side we have no mechanical contact to the coating. So and we have a one-step forming process as compared to mechanical stamping, where you have typically a 2- or 3-step forming process.
So you save already time?
No, not really. yeah, and the hydroforming process takes some time. It is a little bit slower than as compared to progressive stamping, but finally you have a stable and robust process, which can better handle pre-colored materials.
So it improves the handling.
Yeah.
All right. Okay. Now I understand. Now another topic that is also here on the fairground really interesting: digitalization.
Yes.
Yeah, we have several halls filled with information technologies. Your machines also already gather data during the production process. Which data can be used for which purpose? I can't imagine on such a hydroforming press.
Yeah, we record all data, the machine relevant and the process relevant data. We use it to analyze the process itself. That means the assessment of the product. We also look to data monitoring and machine status monitoring. That means we look for the components of the process to be able with smart algorithms to predict the maintenance and to reduce the downtimes.
Yeah. Okay, so how can I imagine, how do you detect when the machine has to be maintained?
Yes, that's possible, yes.
Okay, yeah. So you have several figures and with the...
Now we're using smart algorithms and analyze the feedback signals of all the components. And also for the process, we, as I said, we can, due to hydroforming, we record, for example, the internal pressure. From this recordings, we can analyze even if we have a good or a bad part, and then this can be used for the inspection, for example, already.
Okay, so when the feedback changes, you know, okay, now the process is not optimal. Maybe.
Yes.
All right.
Yeah.
By the way, is there any question from the audience on that topic? If not, I still have some question. Let's have a look to the future. On which topics do you work right now, and which aspects do you still want to optimize in your machines? What's up to come?
Yes, we continuously optimize all our machines. That means on one side the mechanics, on the other side the hydraulic systems. We try to bring new innovations into the production equipment. In the special case of the metal bipolar blades or the forming machines from metal microstructure blades, we're still optimizing the forming. As in the question before, the digitalization industry 4.0, we try to still optimize these topics, and also for the subsequent processes, we try to reduce the cycle times of cutting and welding. We're still optimizing the handling and the automation issues, and yeah, of course, we still constantly develop and make further improvements in all our machines and all our processes to give our customers the best production solutions for their tasks.
So when I understood you right, you're selling this hydroforming presses.
Yes.
Now for a customer who wants to build a whole serial production or a whole production line, how do you work together maybe with partners to guarantee the good communication between the machines?
Yes, this is the same for all our machines, because for the metal bipolar blades or for the hydroforming, we deliver the forming press with a decoiling system and the subsequent process of cutting and welding. For the sealing and for the coating equipment, we work together with partners. And but nowadays, the automation and all the control systems of the different equipment can talk about OPC interfaces and so on. This is not a major topic today anymore.
Not a big topic?
It's not so big topic to have the integration of all the components of one system.
Okay.
Yeah.
All right. In the end, maybe the serial production is interesting, I think, and we will get with that further decrease of production costs of fuel cells and of electrolyzers. What do you think? Which such or how big or on which amount, how many percentage reduction of production costs is possible in the near future with mass production or with the more synchronized production line?
Yeah, to give a quantitative guess is difficult because there are many parameters which influence the price finally. One is, of course, the economy of scales. On one side for the materials, but of course also for processes and handling times or the automation of the whole process. Another point is, of course, that product design has to be adapted to the processes itself, because for example, you have a welding line length, a welding length of 9 meters. Is of course takes more time as compared to 5 meters. That means that the product design has to be adapted to the processes to save money and costs, and to reduce the cost on the other side is this economy of scales for a full automatic production line. With increase of the quantities and the volumes, you will reduce automatically the costs and of course also the costs for the materials.
Okay, so your answer is it depends.
Yeah, it depends on the design of the plates, of course.
The plates, but okay, then the question may be a little bit different. Are there significant cost reductions possible in the future? I hope so, because we are still on the beginning of the development, are we?
Yeah, yes, of course. Also there will be a significant reduction of the costs if the volumes increases or raise up to some millions, because then you need full automatic production lines. Then, of course, the invest will be done. Someone will invest the money to build up such a full automatic production line, and then with this automatic production line, the costs will significantly go down. And as I said, as you can imagine, if you buy a coil for stainless steel with 1 ton, is much more expensive than if you buy 50 tons.
Yeah, of course. And I think your machines will be part of this process. Time is running. We are already through our 20 minutes talk. Thanks to the audience for joining us here for this topic. And thank you, Mr. Müller, for answering my questions. Yeah, thanks a lot.
Yeah, thank you.